Hello, I'm going to share our work with you today about requirements-driven configuration of emergency response missions with small aerial vehicles. So UAVs can be used for all sorts of medical emergencies and other emergency response missions. In each of these applications, there are many commonalities between tasks that the drones will perform, but there are also some unique differences across the missions. And for that reason, we set out to design a software product line. One of the things that makes our product line unique is that we envision using multiple UAVs that would work in a semi-autonomous way in partnership with humans. We started our process by collecting a number of unique use cases. Each of the use cases was derived either from our own practice, by talking with different stakeholders, by examining white papers or YouTube videos. And basically, at its essence, our process is a clone-to-own approach. And I'm going to explain the aspects of that in a minute. But there were three primary activities. These were collecting the use cases and defining or specifying what was to happen in each of the mission types, creating feature models for each of the missions, using a clone-to-own approach, and then merging things back into the domain-level model, and then using activity diagrams to specify the temporal constraints or the ordering of tasks within each one of those missions. So here's an example of ICE search and rescue. On the right-hand side, you can see some pictures that come from a website and basically show how a fire department is using or planning to use drones for ICE rescue. And this is an example of the kind of source documents that we used. So on the left-hand side, we have our ICE search and rescue use case again. On the right-hand side, we have another use case, this time for traffic accident surveillance. And you can see that there are a number of commonalities. For example, the blue highlights show things to do with search. On the left-hand side, plan area search, and on the right-hand side, initiate area search and plan routes. There are many other examples of this. Both of the missions have takeoff, both have performing the search. They also have differences. On the left-hand side, we see the mission has flotation device delivery, whereas on the right-hand side, in the purple, we see that there's a special information gathering feature that's to do with surveying the traffic accident. So commonalities and differences across these use cases. The next step of our process was to take a use case. You can see we're focusing first on ICE rescue, to take a use case and to construct a feature model. And you can see the initial feature model for ICE rescue on the left. We experimented with different levels of granularity of our feature model, but in the end, we decided that the purpose of our product line is to support emergency response, and we wanted the feature models and the other aspects that we were modeling to be meaningful to our stakeholders, such as our firefighters. So we decided to make our features kind of more akin to visible features and tasks that they would be performing. So now on the right-hand side, we see the feature model for traffic surveillance. The blue nodes on the right represent variation points that were visible to our stakeholders. But we also observed that there are variations within these features. For example, in the map-based route generator, the way routes are generated is different for ICE rescue versus traffic surveillance. And in image collection, the trained image model is appropriate for the scene, whether it's trained to recognize victims in the ice or to survey traffic. And so variability points can represent either completely different features or internal configurations of those features. Once we've cloned and modified a feature model, we then merge it back into the domain model, and here you can see an example of the merged model. As we merge the models together, we often recognize that there are cross-tree constraints, especially requires dependencies, and you can see some examples of that here. Next, we modeled activity diagrams for each of the missions. So in our particular domain, not only do we have to configure features, make them available for different missions, but we need to order the execution of those features in very specific ways. So you can see here an activity diagram represents the steps that the drones need to go through as part of an ice rescue mission. And here's another example for accident surveillance and a third one for a fire surveillance mission. So you can see that the ordering of the features is different. The process we used for creating each of the activity diagrams was to start with an existing one and to clone it and then to modify it. Given the naming similarities, we were able to use a very simple algorithm to merge everything together into this large activity diagram. And then we used this activity diagram to guide the configuration of the mission. This had several benefits for us, including the quick configuration of the space. So this is an example that was taken from a prototype demo we did with the firefighters in South Bend. You can see the drones flying and the firefighters on the river. And the firefighters have told us that emergency scenarios are very noisy, very fast-paced, high stress. And in the middle of this scenario, we expect them to be deploying drones and specifying missions. So our configuration of our product line is a little different from other product lines. We don't have the luxury of configuring, testing, and then deploying. We need to specify the mission and deploy as is. And therefore, our activity diagrams allowed us to constrain the sequencing of the order in which tasks will be performed so that we could perform some testing prior to configuration and deployment. So based on the activity diagram, we created a question tree that allows us to select any of our expected paths through the activity diagram. We ordered those questions into this decision tree and we built our configurator around that. So now I'm going to show you a demo of our configurator as prepared by Maxime van Spraybroek. On the right-hand side, you can see that there are several options, river rescue, ice rescue, that are pre-packaged and pre-planned, and the user can click on one of those and start an already prepared mission. At the bottom are options for create mission or manage mission, and I'm going to show you an example where the user chooses to create the mission. So the first thing that the user has to do is select the type of mission. In this case, they're going to select environmental sampling. Then they answer a series of questions, and as they answer the questions, you can see that the mission starts to emerge on the right-hand side. When they finished, features that are configurable are highlighted in red, and they can click on them and they can configure specific features of that particular task. Once the user has configured the mission, we generate a JSON file and we send that to the backend, to the server. The server takes the JSON specification, translates it into a state transition model, which it uses to configure and to monitor the mission. We also generate individual specifications which will be pushed onto the drones. This represents our current work, but I'm going to show you a very quick demo of the first part of that process. Here the user has specified a region to be searched. The 3 active drones are all dispatched to perform the search. They synchronize their takeoff so that they all travel to their first waypoint at a unique altitude. They start their search. You can see the orange and the greens are still continuing theirs. Once they complete their search, then the drones will again go to their unique altitudes for the return trip home. We performed a preliminary user evaluation with 12 additional use cases and 5 participants, all of whom had experience flying drones. We showed them a training video and then we asked them to configure 3 different missions. Our first research question was basically a test case in which we used the configurator ourselves to configure all of our use cases, the initial ones plus the additional ones, and we found we were able to configure all of them. The second question asked the users for feedback on whether the wizard asked the right questions, and they said it was very helpful. Does the visualization help you understand the current mission configuration? Which they replied yes. And then if they had suggestions for improvements, and we received quite a lot of useful information, helpful suggestions about the terminology and about the way we generated the mission in response to their questions. Finally, we considered our lessons learned. First, we considered our use of informal use cases, which we considered beneficial because they were more useful during the requirements elicitation process, and we had many stakeholders. Secondly, we considered our use of activity diagrams for constraining sequencing, which we chose to use because of the additional safety and the speed at which missions could be configured and flown. However, this is a focus of future work, and we're looking at other ways to allow for a more flexible configuration of the mission. We also considered the incremental versus Big Bang merging. The use of the incremental approach tamed complexity, and we found it easier to perform the merging that way. And then finally, we looked at the granularity of our features, which we specifically modeled the way we did because we found that features at that level were better understandable by our stakeholders and could be used for both communicating and monitoring the mission. And that is the end of my talk. I hope that I'll have an opportunity to talk with you and to answer any questions that you might have. Thank you.